People can hear on the stream now.
Is it?
People can hear it already.
Sorry?
People will be able to.
Yeah, it's fine, it's fine.
Can we just check the stream and see it?
Yes, let's yes, we don't have anybody here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, cool. Thanks. Okay. Thank you very much.
So you're going to be running something on here first?
I probably won't. If everyone's going to take part in it, then yes, I can. If they're not, then I won't. So I'll see who wants to do it. Just if somebody doesn't, I'll just get around with it. Oh, you made it. Oh, yeah. No.
Right. Is that for
Let's get home.
Sorry? Bloody hell. Standing right in front of the camera, right?
Okay, well, I'll put my stuff down and I'm going to get some coffee because that'll be able to take on the same work. Good?
Evening. Time no set.
Less than 24 hours.
Welcome. What time is it?
First one?
It's 1 minute past. So, welcome everybody on a final 26th, yes? 26th, I think 26th class. Let me just check. It's really 26th, I think it is. Yes, 26th class. Next week we will have new course starting. So today is the last meetup. I would like to welcome everybody to the game. So first of all, obviously, Phil, who will lead the main part of the course. Phil will be talking about Catch 2. So that's the testing framework, which Phil is author of. And he will tell you everything there is. Now, at the beginning, for those who want to participate, we will be doing, we'll be passing the assignment. The idea is for people, including me, it's to complete that within a week. As far as I understand, the coding, which I didn't see, sadly, should take up to 8 or 12 hours. And after that needs to be submitted to these two gentlemen for a test. They will run the test and then they will talk to your suspect, and if they feel that you completed the test properly, you will be graded. If not, sorry, try another time. So the first thing, if everybody who is taking the part in a test...
Who wants to take the test first of all?
Take the one page, is NDA, and sign it. The NDA basically states that you will not share the solution with other students. It's about making sure it's fair, and
It's a promise not to cheat.
yes.
It's probably not cheat, and just give it away to others so they can cheat.
So it will stay honest, and obviously there will not be penalties. We will not take you to court.
And also, because if you decide you don't like our test grade, then you can't come after us. You agree not to come after us if you don't like the grade.
Then obviously standard thing, can you please put your name clearly? Otherwise, if I find unclear name, I'll just write Java code lover.
So yeah, to fill it out, at the top where there's the big empty line, the first one, and please enter your full name. There's an optional clause in the middle which you can sign. If you sign that one, then that means you give us permission to tell other people about your test information if you communicate with us electronically. If you choose not to sign that, you can still get us to do it, but you have to give us a written letter to say you give us permission. So
What would you do?
if you want to say to them, I took this test and you want us to confirm for you that you really did and that it's valid, then...
So you go to an interview and
yeah,
say, I've done this.
but if you don't sign that clause, then you have to send us a letter to authorise it. If you do that, then we'll accept an email, but if someone spoofs the email, it's not our fault.
So, as I said, 1 week to complete the assignment. For online users, if there are any, I'm not sure if there are anything, let me just check quickly if somebody connected already. Yes, there's 2 people watching. So for online people, if you didn't send me an email with your photo ID, please do send me the email. You can find my contact details on our website, or talk to me on Slack, and I will give you my email address and then send it through. A little bit of update. The new course, as I said, starting next week, and so far the response we have is overwhelming. We have over 190 people sign up on our main page. I do honestly hope the 190 people are online people, because I'm just wondering how we're going to feed them. Plus, we have 29 people sign up on the Skills Matter website. So definitely 29 people said they're coming physically. Potentially is up to extra 190. So it's amazing amount. Now the course will be led. We will be using as a base a book by Bjorn Strostrup, Programming Principles and Practice using C++, 2nd edition. My advice: buy book. Yes. My recommendation is get the book from the legal sources. Yes, the person who downloaded the book done amazing amount of the work, and it's a payoff for him. Yes, so it's our token of our appreciation. You're not paying for the course, which is great. So at least let's. No, I'm looking at everyone.
We don't want to know where you get an ebook from, okay? We don't want to know. Question,
a request from me, kind request: take the legal copy. Now, a small complaint. We've been put in a naughty corner. We've been put by the Skills Matters in a naughty corner with regards to food. Somebody complained that too much food is missing from other meetups, and we've been told that if we've been caught, we will be kicked out from the space. So please make sure respect the other meetups, or we might lose the space, because the other people pay, and they're quite cross. They come and there's food missing. Final thing, I'm looking for contacts in companies like Facebook, Google, Bloomberg, Microsoft. Yes, I'm looking for sponsors. So if you know somebody there who might get us in touch with the right people, come back to me. Yes, it will be really handy, because as you can see, there's quite a few people. There is a demand for that. We're doing this at the moment from our own pocket, and obviously if we could get some sponsoring, yes, even things like buying books. Yes, there will be people who can't afford buying the books, because books there cost like 40, 50 pounds, even travel and so on. So that would be really helpful, or even paying for the teacher's time. It would be an amazing thing to do. So that's all from me. Ollie, Tristan, do you want to add anything?
No, just take it through. I'll take the people. Who's happy to sign this and do it? We've got 2 so far.
So from me, thank you very much for Tristan and Ollie time, and thank you for your time for coming and committing the time. I'm really appreciated. The project was, I didn't expect it to be so successful. And obviously put your names.
Can we grab one chairs? Yeah. There's a pen going around. I don't have one.
Okay, fine.
Oh wait, we've got 3 so far, haven't we? No, is it 1 or 2? We've got 2.
2. Sorry, do you want to participate in test? In the final assignment test, or do you want to just join the
We're giving out the final test today.
This is a very strange time to come to your first session.
If you're coming in here and you already know C++ grades, then feel free to participate. But if you don't, then don't worry about it.
You could argue that would be test first.
It's actually a very smart thing to do.
I mean, if we've only got Joshua and Como, then two of us might go outside and discuss it.
Oh, you have to discuss it.
Well, do you want to know
Is
what
it-
it is?
Oh, okay. I thought you were going to say email or something.
No, we'll cover it now for everyone who signs. If you want to do it, then we'll sign. If you don't worry. Some things I can share with anyone. The basic principle of the test is that you've got until 7 PM on May the 1st to submit. So that gives you about a week, obviously. There are two ways you can submit to us, or three technically. The preferred method is if you go to bitbucket.org and you get an account. If you do it this way, then you obviously just push to your repo, share it with us. We will take care of the deadline. So you don't have to worry about getting it to us by 7 because we will grab whatever the latest thing you pushed there is. So just don't forget to push it, and you'll be fine. We'll take care of it. You would then also have, if you do it that way, we give you 24 hours additionally to tell us to take an older commit. So if you discover that you accidentally pushed some garbage on top, you have 24 hours to say, I'm going to take an older one. You won't take a newer one, but we will take an older one. Failing that, you can of course just come here and bring a USB stick, or you can just email it to us. Those are all completely viable options. In terms of sharing the actual specification with you, we actually have it on Bitbucket, so again, if you take the Bitbucket route, it's super easy. If not, then we will email it to you.
The issue submission is final, or you're going to tell us, okay, you did well, and this part is missing?
So there's two. So the actual specification covers it, but basically the gist of it is you'll complete it. We will then look at it, and then we'll go through it with you as well.
Do I need to finish this as well? Because I'll be signing up myself
You're
with
the
myself.
representative.
So I need to sign up.
Oh, well, you don't count. You're obviously you're part of CP.
Because funny, you know, representative represented by Tom Breza and student Tom Breza.
Yeah, you don't need to be worried about it. Okay, right. Who's going to take the Bitbucket route? There's two. Okay. Go to bitbucket.org and sign up.
I am.
Cool. Okay. So how many people have we got again? Is it 4? Is it 4?
There is one person online who sent the thingy.
Okay.
Miguel Carvajal. Yeah.
Right, so as soon as you've got signed up on Bitbucket, I'm going to add you to our lovely C++
I'll forward this only to you. To which email address should I forward that?
Sorry?
The Miguel thingy. Where should I forward this?
Just send it to over@int.net.
So he needs to complete the NDA and then.
Yeah.
And obviously he will be as well on a Bitbucket.
So let me know when you've got your Bitbucket account.
Do you have a preference what you want people to use?
In terms of, so Bitbucket's ideal. It also makes your life easier because we're responsible for your deadline. But it's really up to you. If you want, we can email you the spec and stuff. So let me sit down. So I'm going to try and get this done before 7. Also, for those of you taking it, after me and Tristan have graded you all, we're going to be handing off all of it to Justin, and he won't know who is who, and he'll be telling us if he thinks we were unfairly nice to anyone. So that way, Tom here really came bias.
Sorry?
I just thought he's going to be the final blind test.
Okay.
Okay, so once we get back, what do you need from us?
Okay, so what's your username or email address?
Horace. Horace.
Huh?
2 underscores.
Horace underscore underscore HORACE underscore underscore. Okay.
Test for Ali, test for Rico.
Yeah, ignore that. Refresh, you should now see the spec. You got it? Cool. Okay, first one.
I think these two are parts we don't.
Blackjack.
Now, what should we name the repository?
You can honestly call it whatever you like. This is going to be the next bit. So your repo to do your files. Go ahead and create yourself a new repo.
It's like on GitHub, you need to have a username.
And then just repository.
What's the difference between Bitbucket and Bitbucket? What's the difference between Bitbucket and GitHub?
Bitbucket allows you to have private repositories without paying. So that's why, because we don't want you to, we don't want people to put their solutions out in public, so that other people might be able to see them. So
Create repository.
There are limits to how if you're going to do a private, you cannot add the necessary, you cannot add more than 5 people. So it's a bit, but if you need to give something private.
Cool. Go to settings. Use group access. Subgroup. Yeah. Nice. Just add. Just make sure you push everything to that group now.
Send me an email.
Is it a private repository or is it
Private. Must be private. Is there an underscore or
No, just all one thing.
Ah,
Okay.
no worries. AWLO CPP London one.
And yeah, that's just my username. That's
Ah, okay, so I don't do a repository name, it's fine. Right, go to your repositories. Click on, go to the main bit, find the logo, yeah. Okay, got access, you've got access to it. Go to your solution again. So, no, there. Settings. product. Refresh the page. You should have control it. When did you create it? Go back to your repo, would you? Actually, can't show it to students, which shows it around. So that's not your repo. Go out of that. 17.
I mean, I just signed it to Bitbucket. I created a repository.
I mean, I already had an account with that before, but the rest is the same.
Sorry?
You need to find the sample or the way around?
Sorry? That's one minute. Sorry?
You need to go to settings and then
Yes, I'll set it.
settings.
Have you got yours now? Yeah. Okay. Go to user group access.
So the second option.
And then go to users.
I don't know who it is.
Right. Yeah, there you go.
What kind of permission do you
Right, and you're all set up. You can look at the spec at home or no one's looking at your laptop, that'd be good. Yeah.
Okay, so I've got access from two people, so thank you.
Feel free to amend and update the fix as you see.
Ah, okay.
Do the test I think to
So you need to sign this first.
why do I get the feeling that we have to use cache?
You don't have to at all.
What's the because I'm for sec.
Are you registered to your payment?
Hold on, what
What is
it should run in
Sorry?
whatever solution we
What is
provide.
this here on the
Oh, I
So
can't.
for the 6 years,
Whatever solution
that's
we provide after all is
right, that's for the 6 years, this ND.
No, it doesn't have to be like.
Basically,
You just
for
need to.
6
We just
years,
need
you
to.
should
So
say what was the
read the spec later. We cover all that.
this assignment. I mean, the 6
Right,
years
you
is
send it,
it.
Kevin?
This is very other for
Yeah.
people.
did you,
But then
do you need the read permission or
So you
not?
won't suddenly
No, so I just need to know your
you start
username.
copying and pasting all the
So
solution
my name and
everywhere.
surname
Yeah.
are
Anywhere.
capitalized.
Yeah, like so. Oh, this is. I mean,
So what username did you
if you take the copy of the solution, the assignment, yes, and put it on the internet and so on, then that will disqualify you as for running for, because then people, somebody else comes, he can take the question and prepare, yes, and a month working on it, and then come back and say, oh, I did it in a day. You need to ask this guy. I didn't know that.
Did you create your own private repo?
Yeah, several, yeah, just created one and
Cool. Okay. If you go into settings, add Polypro, I should show up as a teammate, and then TC print up. Big show. Cool. I think.
I was asking you if you need a read or more permission.
No, just read is fine.
Yeah,
Just
just
read.
read.
That's perfect. Yeah.
Yeah.
Give me a sec. I'll get the
Yeah,
share.
sure.
So the main requirement is to
Share the spec.
share
Code.
to in a 6 year is something standard
Yeah. I think we might. I doubt we'll be using this for 6 years. So we're limited to 6 years, like you said.
and
Don't share it, and then I'll get you damages.
Yeah, okay. But
Alright, I don't think there's anyone. Is there anyone else who needs to be added? We've got doing your shoes done. Oh, I think Phil can start whenever he wants.
Ah, you ready?
Yeah, I think we're ready. Yep.
Okay. Right. So, good evening, everyone.
Hello.
So I'm Phil Nash, author of Catch, amongst other things, and Catch 2. As you can see from my t-shirt, it's actually last year's edition. I've actually got a Catch 2 t-shirt now, but it's in the wash. But you can get limited edition Catch 2 stickers if you haven't got one already. So grab one of those. As the slide up here says, we're going to be working through a code base a little bit later. So grab that now if you haven't got it already. So if you're ready.
Hello.
Evening.
We'll have to fetch you a
I'll just sit
chair.
and watch.
No, don't worry. We'll grab you a chair. Yes.
I'll get a chair. Can I just leave this here?
Yeah, of course.
I'll carry on because I've just got a few introductory slides anyway. So does anyone still need that URL? I will put it up again a bit later anyway. Or you can just go to the CPP London Uni collection and it will be there anyway. So what I've done is, by way of introduction, I've done a bit of a mashup of two of my conference talks. So this is just a few slides from one talk and a few slides from another talk fused together. So it might be a little bit jarring in the middle. So this title slide is from my Catch 2 talk, where I actually introduce Catch 2 itself. I'm mostly going to use the first part where I just go into a bit of background on testing. I thought that'd be useful to start with. I've been talking about Catch 2 here. If you haven't used Catch before, you might actually wonder what the difference is between Catch 1 and Catch 2. For our purposes, it's not quite so interesting tonight. It's just that sometime last year, Catch 2 rebased on C++ 11, and it's a big breaking change. So I thought it was worth the major version bump. There's a few other new features as well, which I had in the original talk. These slides are also brought to you by the help of classic programmer paintings, just to lighten things up a bit. If you haven't seen this Tumblr, it's really fun. It's just a load of classic oil paintings, but with the title was changed to something to do with software development. So I thought some of them would make an interesting backdrop to my slides. And also, of course, where would we be without a few tweets? So one or two of those sprinkled in as well. So back to the topic. So just the fundamentals of testing, and this is a question I think any of us can ask, no matter how experienced we are, even if we've been doing TDD for years or if we're absolute beginners. And that is, why do so many people not write enough tests? And I could just say not write tests at all, and that would actually cover a lot of people. But even if we are writing tests, when do we ever get to the end of a project and say I wrote just enough tests? So all of us realise that we could be writing more tests, so why don't we? What stops us? That's the question. And there's a lot of reasons that people might bring up, and one of them might actually be that I'm just getting started, I haven't really got that far yet. And if that's you, then you're in the right place. But even if we've been doing this for years, we might still ask the question. And most of the reasons boil down to some variation of just don't have time, or I already know that it works. Why am I going to do that testing again? Or sometimes that's what we have testers for. We don't hear that so much these days. But the question is, how do we know that our code works if we're not testing it? And for most people, that's going to just be, well, I just run it and see what it does. Or maybe feed it some parameters or press some buttons, whatever it is. Observe the behaviour and compare that with our expectation in our head as to what it was meant to do. And there's actually nothing wrong with that. And in fact, for a lot of us, that's what got us going in the first place. This idea that we can type stuff into a computer and it will actually do what we intended it to do. It gives us this great feedback, this buzz that takes us on to the next thing and the next thing. And so in that sense, manual testing, because that's really what it is, can actually be quite fun, which is not a perspective that most people have. But if you think of it that way, that we're doing that manual testing, actually gives us this great feedback. But there's a really important caveat to that, and that's only true the first time we do it. That is, once we tested that something works, we move on to the next thing. And do we go back and test that the previous thing still worked? And then we do another thing and another thing, you get an n-1 problem. And that's where we break down, and that's where, as humans, we're not really good at doing these tedious and repetitive parts of testing. Because they are repetitive and they are tedious. We're just not really good at doing that sort of thing, most of us at least. But you know what is? What's really good at doing tedious, repetitive tasks and not complaining about it? Computers. That's what they're for. So when we're writing tests, that's what we're doing. We're just automating that dull, tedious, repetitive part so that we don't have to do it. We're actually saving time and effort by doing it. So when people say they don't have enough time to write tests, what they're really saying is, I don't know if my code works. Simple as that. So let's flip this around and ask, why should we write tests in the first place? And it might seem obvious, but there's actually two parts to this, and I think it's worth considering the two parts. So the first part is perhaps the most obvious one, that we want to show that our code is correct, that it actually does what we intended it to do. And if you write a test before the code, then it's acting in that capacity as something that will tell you when you've got it right. So it'll be red until it turns green, to use that metaphor. But once it does start working, it flips into a different mode, a different role, where it acts as a regression test to tell you if you then break it later. That's the part that protects you from the tedious and boring stuff. And the reason it's important to consider those dual roles is because they can actually have different value. In the tests we write in order to get to the first stage may become good regression tests later, but not necessarily. And sometimes they can actually hold us back. So it's worth keeping in mind, sometimes we also need to delete tests. A lot of people have difficulty with that. But when you realise that they're playing these two roles, that can help. So I mentioned writing tests first, and I want to get into this a little bit more in a moment. But just briefly, first of all, why would we do that? A lot of people find that odd. A couple of points here. First of all, I've said codifies our expected outcomes. And what I mean by that is really what we were saying earlier. When we write code, we have some idea in our head, hopefully beforehand, what we actually expect it to do. And then we mentally compare that later. But this puts it into code at the point that you have that in your head. Sometimes you can have an idea in your head, you go and write off the code, and you forget what you're actually trying to do in the first place, and you go off and do something slightly different. Or maybe do too much or not enough. And that can help us to guard against that. And the other part is really interesting, and it's actually quite a big space I've just summarised in one phrase, which is it guides our design or exerts design pressure on our code. I'll dig into that a little bit more later, but this is really where the true value of test-driven development comes in, by actually shaping the design of our code, not just the code itself. So this is now actually flipping over to slides from a different talk, where I talk a bit more about TDD. So it stands for test-driven development, which you probably knew. Some people do prefer to say it stands for test-driven design, for reasons I've already touched on. It's actually the design of your code that it's really shaping. It's the design pressures that are important. But whatever you put on the right-hand side of the equation, the left-hand side can also vary. There's all sorts of things that you can, principles that you can hold first to drive the way you develop or design your code. Some of them, like BDD for behavior-driven development, are actually closely related. Others, like domain-driven design, are slightly different, but they're all ways of driving what we're doing by holding some principle first. No one of these things is the right way. That includes TDD, so I'm not going to say it's always the best approach or the only approach. But it is an important tool that I think everyone should be familiar with. So, a little bit about the TDD cycle. You may have seen this before, sometimes known as just red-green refactor after the three main stages. So, I want to dig into this a little bit. So we always start in the red phase, where I've said write a failing test. Really important that we always start with a failing test. If we don't do that, then we're not doing TDD. Then we might write a test that works first time. Sometimes that's just what happens, but we should always question why. Maybe we didn't expect that, or maybe it means that we generalised a bit too much earlier. We'll come back to that later. Or sometimes that's just because we did another test. But we need to write a failing test before we can move on beyond this step. So that's really important. But the other word I want to draw attention to here is the word test. We'll talk about assertions in a test framework later. That's what we commonly associate with this. But actually, just the compiler failing can be a test. If you write code that doesn't write against code that doesn't exist yet, and the compiler fails, that's a failing test. And that can be sufficient to take you one time around this cycle. And we'll use that a little bit later. So once we've got our failing test, we move on to the green phase. So it's write just the code to make the test pass. Emphasis on the word just there. Well, what we're not doing here is spending a lot of time on it, writing clean code, worrying about performance, efficiency, or anything like that. But we just want to write the minimum thing that will get the thing to work. And often that will involve like returning a constant, for example. So we know we're going to go back and change it. But what we want to do is make sure that we've got a test that's going to force us to do that first. So if we return a constant and then we write another test that breaks that, then we're forced to generalize. So that's quite an important point. We'll hopefully bear out in the demo. Once the test passes, only then do we move on to the refactor phase. This is where we can do our cleanup and we can worry about other things that are not directly to do with the behavior. And refactoring just means literally to keep the behavior the same while changing the code for some other metric like code cleanliness, performance, or whatever. We won't always refactor every time round, but we should always consider it, because if we leave it too long without a refactor, our code will end up in a big ball of mud, and that's what we want to avoid. This is where the design pressures come in that we'll talk about a bit more in a moment. Those are the traditional 3 stages of TDD. Put an extra one in there as well. Just this step that we visit between refactor and writing a failing test again is just to ask the question, are we done yet? There's a very specific place in the cycle that we ask that question. The reason I want to draw attention to that is because there's actually a difference in mental modes in each of these stages. When you're writing a test, you're in very much a design frame of mind, thinking about requirements, expectations, high-level stuff. When you're writing the code to make the test pass, you're in an implementer's frame of mind. It's very different. Different mental resources you can draw on, and you can get distracted by different things. But at this point, we're actually flipping back into the design frame of mind. It's a very good time to think again about requirements and say, what do I need to do next? Or am I done? As opposed to when you're writing code and thinking, oh, that would be cool if I did that. It's a different mindset, so it's important to keep that in mind. So the TDD cycle itself is actually pretty straightforward. There's a few things you need to bear in mind that we'll tease out a little bit later. But I can show it all in one slide, nice and simple. We'll revisit that thought in a moment. That's the what or the how of TDD. We also wanted to go into a little bit more about the why. Why we would do this. We sort of talked about that a little bit earlier because, as I say, these are slides from different talks. But here I've actually pulled up a whole list of potential benefits that we get from using TDD. It's not an exhaustive list, it's just a selection that I wanted to highlight. And I'm not going to go through all of these one by one. We could easily do a whole day on this stuff. In fact, I've got a 2-day workshop on this coming up. That's how extensive it can be. But I want to highlight first of all the first one, that perhaps the most obvious one, that we end up with a good set of regression tests. In fact, if you're following the TDD cycle strictly, because you don't write any production code until you have a failing test for it first, you will just naturally end up with 100% test coverage, which is actually the second one. So, very good set of regression tests that will cover all of your code, in theory. But as I say, sometimes those regression tests can get in the way. But then the next one I want to highlight is that it leaves the code more testable, which might sound like a circular argument, so that's why I put in a few sub-points off that. Again, not exhaustive, but this is where these design principles that I talked about come in. Making your code more cohesive, giving you better isolation and so on. These are actually quite difficult concepts to build into your code, and you really need to have a lot of experience and knowledge to be able to do this well. And even if you have, it's just really hard to do it. The beauty of TDD is it will tell you right at the start if you're not doing it, because your code would be hard to test. You'll often hear TDD practitioners talk about the test talking to you, telling you that you're not building in these design principles. The code is hard to test. It's probably because you've missed one of these. And I say it doesn't automatically fix the code. You do still need knowledge and experience to do that, but it will guide you to where the problem is and tell you straight away at the start when it's easier to fix. So it's a really important part of TDD. And the last one I want to highlight, I call it client perspective. What I mean by this is that if you're writing a test first, then before you've even written the code, you're gaining the experience of what it's like to use it. You get the user's perspective of your code. Particularly important if you're writing a library or some code that's going to be reused in a few different places. If you're writing from the inside out, very easy to end up with a suboptimal interface because you're thinking from the implementer's perspective. If you're writing the test first, you get a taste of the user right at the start. I think that's serious enough for a moment, so a little bit from Twitter. Okay, break's over. So we talked about all the good stuff, and a lot of people just stop there, but of course there are some problems, not necessarily TDD itself, but just the approach that some people have or difficulties they have applying it. Again, I'm not going to be exhaustive here, but I just wanted to pick out a few key things to keep in mind when you first set out. The first one is it's hard to learn, and contrasting that against the TDD cycle I showed you earlier. I said it's a nice simple slide, just three stages, red, green, refactor, easy to understand, easy to follow. So when I say it's hard to learn, what I mean is it's all those bits in between, the bits where you need that extra knowledge and experience that I talked about, but it doesn't get you out of. If you don't have those, then it can actually be quite hard to get up and running with it initially. And as a result, when you first start out, your productivity will actually go down before it comes back up again. For most people, it takes a couple of weeks, I'd say, of really applying TDD before you really start to get the feel for it and the benefit of it. And if you're newer at programming in general, it may actually take a little bit longer because you will need to gain experience with those design principles that I mentioned as well. And a big problem associated with this is that a lot of people, they'll just start using it in their main production code base straight away when they've got pressures for deadlines and delivery and other people asking what's going on, and the productivity is going down, so they give up, blame TDD and never touch it again. So don't do that if you can avoid it. Instead, you should use what we call deliberate practice, which is sort of what we're doing here really. And key tool of that is coding carters, which you may be familiar with. It's just where you take a small self-contained problem that you can work through pretty much in isolation without any risk of failure, without any deadlines, just simply to practice some new language or tool or technique, often repetitively, so you can refine your ability. So that's a great way to practice something like TDD, and it's also a great way to demonstrate it. So that's what we're going to do for the rest of this session tonight, and that's where we're going to use the code in the repository that I showed earlier. I will show that again in a minute. What we're going to do though is a game, hence the name of the repo, Snakes and Ladders. So sure everyone's familiar with the board game. This particular board is one that my kids used to use until it wore out recently and we had to buy them a new one. They still love it. And I'm actually going to model this exact board because it has a couple of properties to it that I quite like for the purpose of this demo. So what we're going to do, I'm sure I don't need to explain everyone the rules, but we'll just walk through it briefly as a problem statement. So we have the grid here of 10 by 10 squares, and actually the fact that it's laid out in a grid is really just a presentation issue. We're not going to get onto UI in this exercise, so that's pretty much irrelevant. It's really just a series of 100 squares, numbered from 1 to 100, and each square can be one of three types. It'll be empty, and again, don't let the pictures put you off, it's just presentation. Either empty, or the start of a ladder, or the head of a snake. That's it. And of course, if it's one of those two, then it will, if you land on it, it will take you to another square, which will be the top of the ladder or the bottom of the snake. Again, the direction that you go in is more a matter of presentation than anything. So it can be useful to refer to these by a common term. So I call them portals, because they take you from one part of the board to another. So I'm going to use that terminology. And in terms of the gameplay, players start on square one, roll a die, so random number between 1 and 6, move that number of squares. If you land on a portal, you're transported to the other end, otherwise you stay where you are. And then the winner is the first player to land exactly on square 100. And that means if you land on one of the last few squares and roll a number that's too high, you miss your turn. That's all of the rules, nice and simple, so it should be a nice simple example to work through. So the first part is how we're going to model the board. So let's just have a look at this in abstract. For example, taking the first ladder between 2 and 38, we've got 3 pieces of information. Start square, the fact that it's a ladder, and the end square. So we just capture that out. Then look at the next one. We've got one between 4 and 14 as well. We'll pull that out. I won't do them all individually, but get the idea. Pull all that information out. We've got our abstract representation model of the board. What we want to do is convert that into code. And with a little bit more punctuation, a bit more so because this is C++, we actually get some C++ code that models that board. Obviously it's not complete. What this is a literal for a standard map with this definition. So we've got to type up there portal. We need to define that as well. So in this case, I'm just going to make it a struct, contains an enum and a target square. So pretty straightforward, I think. There's other ways you could do this. This is the way that I thought worked quite well. Before we move on, is everyone okay with this code? There's nothing surprising about this?
Type.
Sorry?
Type.
Type. Well, type is the enum.
Oh, okay.
Yeah, so enum is called type, and then we're declaring an instance of that. So
Type with a capital T is the type, and type with a little t
is the value.
If you want, you could have put the word type at the end of the curly braces of the declaration for the enum class.
Okay.
There's a variable called lowercase type, and the type of it is the enum class.
Okay.
The code's not going to get a lot more complex than this, so you shouldn't have any problem with it. But if at any point I do show you something that you haven't covered or not so familiar with, or you just don't know my style, let me know. We'll talk about it a little bit more, but shouldn't be a problem, I think. So now we're going to actually go to some code. So there's that URL again, in case you haven't already got it. But I'm not going to leave that up there for long because I'm going to come out of here. So just make sure everyone's got that now. Who's going to get it?
Yeah.
Good. Okay, so what I'm going to do now, switch room. Okay, so this is C-line. Does everyone here that's going to be following along have C-line?
Yes. Yeah.
Or is anyone using anything else? No? Good, okay, because part of this is we're going to use some of the refactoring tools as well. So we'll demo that. Has everyone got that code base that from the repository open? Okay.
And all people downloaded?
Yeah. So just showing the main file here. If you do Factosh, do that. And if you can see at the bottom of the screen, I've got Presentation Assistant enabled, which means that when I do a shortcut, I'll show you what it is. So on a Mac, it's Command 1. On Windows and Linux, Alt 1 just toggles the sidebar. So we've got our main here. But what I've got in this folder under snippets are some bits that we're going to copy in the course of the demo just to save a bit of time on some noisy code. So we'll come back to that in a moment. Main itself is just the standard hello world so far. What I'm going to do, if we go to the snippets now and go to, let's open it up, portals.cpp, you'll see in there, this is basically the code that we showed in the last slide. So what we're going to do is just copy that code into the start of main.cpp, just before main itself. And if you do that, you should find that the C-line is telling you straight away there's an error. So what we can do there, if we actually put the cursor on map, you can do Alt-Enter, and it works, and it will automatically put the include in for you. I don't know if that was a feature you're familiar with, but it can be quite useful when it works.
Very comfortable.
So everyone
C-line adverts as well as
works for me. Everyone got up to that point? Okay, so
Can't I suggest something?
yeah.
Initialization of portal with the static storage duration may throw unexpected exception
We can
that
ignore
cannot be
that.
called.
We can put a thing in to suppress that. It's going to be fine.
I don't think
Trust
we have
me.
a memory shortage for this much.
Yeah, especially on startup.
Yeah.
Okay, so we've got our map. Now, we haven't got onto any tests yet. What we want to do is to see if this actually works. What sort of thing might we do? Looking down here at our standard out, maybe we just replace our string with a call to portals where we look up, say, the first ladder in this case, and on there we can see we can get the target square, and we might just want to see what that is. So if everyone's got that, we just do Control R or Shift F10 on Windows to run it.
38.
Sorry, you got that?
38.
38, yeah. So that's what you would expect. So this is an example of what we were saying in one of our first slides, where you just run it to see what happens. And it sort of works. You know, we can see it's 38. But there's a few problems here. In fact, there's lots of problems here. We're going to fix them all one by one. The first problem is that, well, you know, if we want to test something else, like another one, we've got to start copying all of this down and then remember to keep going back and looking and checking that the results are right. So we want to be able to have the code check the values for us. So we might pull this out of our standard out and make it into a condition like this. And then we want something to test it. and we could do assert for that. Again, we can alt enter on assert to pull it in from the standard header. So assert is just built into the standard library, only active in debug builds, but if you run that, when it all works, you get no result. If I change that to some nonsense figure, just to force an error, you can see it tells us assertion failed, and this is on my Mac. It might be different if you're running on Windows or Linux. It tells us the code that failed. In my case, it tells us the function, the file, and the line number. Your results may vary, but that's actually pretty good. We've got quite a bit of information there about our failure, but what we don't see is the actual value that we got. We know it's 38 because we saw it a moment ago, but if this is a real test failing, it'd be really useful to know in the output what we actually expected to see versus what we got. There's not very good ways of grouping these. There's a bit of a scalability issue. So this is where test frameworks become useful. It's just like taking us the step beyond what we can do with a simple assert. So the next step is to actually start using test framework. So of course we're going to use Catch, the one that I wrote. That's already there in the project, so all we need to do is include it. So if you go to the top of the file and do include catch.hpp.
Do you not need a define so that it gives you a main? Okay, you're going to do that.
Yeah, we're way ahead of it. Before we come to that, what we're going to also do is change our int main into test case, test underscore case, all caps, and change assert into check. Did everyone get all of that?
Oh, you allowed a test case with no.
Yep.
Sure,
We haven't given the test case a name. Sorry?
That used to be an error once.
Years ago. Yeah, we'll do a test naming in a moment. This is just like the minimal steps to get from where we were. So if everyone's got that you should be able to compile that, but it won't link. So you get something like this, hopefully, which is not particularly friendly error. But the reason for that is because catch is a single header, but if you want it to generate a version of main for you, before you include it, you have to define catch config main. So just put that at the top. That will tell catch to generate main, but also all of the implementation files part of catch will then get compiled into this file, if that makes sense. So it's as if you bundled all the what would have been CPP files and put them in here. That should then This is not my usual laptop, so I'm struggling with the function keys here. It will take a little while to build because it's building the whole of the catch library as well. We'll address that in a moment. Did everyone get that? So just those two lines alone will actually give us a complete application with command line processing and everything. As you've seen, we can include test code in this file, but because it's compiling the whole of catch every time, it's not the best place to do it. It's going to take too long to recompile. So the next stage is to create a new file. If we go to the root of the project and do Command N on the Mac. I can't remember what it is on Windows, it hasn't shown it there. We can say new source file. Let's call it tests. You can add it to Git or not, it's up to you. First thing to do is include catch again. We don't need the hash define this time. We only do that in the one file. Very important. and then all of the code after the include in the main file. You cut that, and paste it into test.cpp. Did that? For some reason that's still there. Okay. So you should end up with just those 2 lines in main, and test.cpp should have just the include and then the rest. And that should then, so the first time you run it, it will take a little while to build again, but subsequent builds will be much faster. Did everyone manage to do that?
Yeah.
Okay. All right, so in fact, we don't need that IO stream anymore because that was only there for our hello world, so you can get rid of that as well. Not that important. Okay, so what else can we do? Let's actually run this. We've seen it run yet. So we've still got a failure in there, if you were following along. Now we can see a lot more information than we had with our basic assertion. So you'll see we've just got a header here telling us the version of catch. And then the test name, we didn't give it a name. So it's generated one for us, called it anonymous test case 1. We did another one, it'd be anonymous test case 2 and so on. It's not particularly friendly, but it's great to get us started. So let's actually go back at this point and give it the test a name. We can just add a string here. We'll call this something like, I don't know.
Ladder 38.
Sorry?
Ladder 38.
38.
Ladder and the number of the square 38.
Square 38. Well, that's just one example. We'll come back. We'll come back to fixing the test in a moment. Just want to give it a name for now. But we're just going to mapping portals. We're going to change this in a moment anyway, so it doesn't matter too much. If you run that again, first of all, you should see it compiles a lot faster, and you should see our name there. Then you've got the file and line number should be clickable of the test case and the failing test itself. We see the assertion as you wrote it, but also, and this is the bit we were missing before, the values of the left-hand side and right-hand side of the expression, telling us that we were expecting 38, but we got 38, we're expecting -1. If you use other test frameworks to do try to separate them out into actual and expected, if you're anything like me, I always forget which way around it's meant to be. So in catch it's unambiguous, it's just the way you wrote it, unless you're trying to describe it after the event. So we go back and fix that, of course, change that to 38, and then it should all run. We're now green, we just got a nice green bar. We don't get any output other than that if it's successful. If we want to, there are command line parameters to show successful runs as well, all the information. But usually this is all we want. Is everyone still up to speed? Should we move on? Okay. Right. So that was the first problem. The second problem is it's not really a very good test, because what are we actually testing here? We're basically just testing that standard map works, which if you've got any confidence in the standard library authors, you're probably okay with that, unless you're actually working on the standard library. Our intention here is not to test standard map, it's to test our board logic. Well, let's come back to that in a moment, because there's some more problems. First of all, here we're actually picking an item that's in the map. If we picked one that wasn't in the map, like 1, if you try and run that, it will fail, of course, but it's giving you a result of 0. Does anyone know why?
These ints are initialized to 0.
Sorry? It's creating a new element and adding it to the map. It's actually mutating the thing that we're trying to test, which is a big no-no when you're testing. So the first thing we should probably do is make our map const. And that will prevent that at compile time. If you try and build that now, you'll get a lot of complaints. So that's going to force us to do something a little bit different. What we need to do now is, simplest transformation is to say, got find, and then we have to dot into that to get the second element, because the map returns a pair, and then from there we can get target. I think I've got that the right way around. Did I get that the wrong way around? Remember? Yeah, so it's arrow first, isn't it?
Yeah.
I knew I was going to do that. So full marks if you got it the right way around first time. So that sort of works. It's not very nice and has other problems, because if you run that now, actually still says 0, at least it doesn't mind. It might vary on yours. It depends on the standard library. So we're actually invoking undefined behavior here. What we really need to do is pull the pull the iterator out. That find returns an iterator. And the first thing we should do is check that we're not at end. So we use a slightly different macro here. So require will abort the test if it fails, whereas check will report a failure but carry on. So by saying that there, we'll actually short circuit the test if we are, should be not at, if we are at the end. So it requires that we're not at the end. Then we can dereference the iterator. Is this making sense? That should build. And if you run that, the failure will now be slightly more informative. It tells us that it's the iterator that's the problem. We don't have anything that will serialize iterators built in, so that's why we get these question marks. But we know what the problem is. So that sort of works, but we're still testing the implementation of map, first of all. And if we wanted to test a few of these, it gets really verbose. The problem here is that it's not map we want to test at all, it's our abstraction over the top of it. We need to raise the level of abstraction. So after all that work, let's delete all of that. And let's start doing this using TDD. What we actually want is some sort of board object that's going to abstract our logic. So let's imagine that we already have it by declaring an instance, which should show up as red in C line because it doesn't exist. Again, if you Alt-Enter on that, it'll give the option to create new C++ class board, which we can do. Let's do it header only. In fact, I'm not going to do it that way. The reason is we want to keep it all in this file for now. So let's just do this manually by wrapping our portals in class board. So that's going to become a member of the board. C-line complains for a moment. It should catch up. So all we did is to put class board around portals. That will now compile. So the next thing is to call a method on it. So I'm going to imagine that there's a method called landOn that will tell us what happens when we land on a certain square. Start with square 1. And this time we can use Alt-Enter to create new function. And I actually want it to, instead of using int, let's make it an unsigned int so that we don't have to worry about negative values. And we call that square. And we want it to return an unsigned int as well. If you want to do this manually instead of using the generator tool, that's fine. But what you want to end up with is something like this. And even that return value is right. because the first thing to do, just remember, the minimum step to make the test pass is to make the compiler work, in this case. So as long as that builds, we're green. Everyone got to that?
Almost.
So of course, if we run that, it works because we haven't tested anything yet. So let's put a check. And we want that to be 1, because it's not a snake or a ladder. That fails because of our 0. So that's now forcing us to generalize. Actually, we could put another constant here, but I'm going to go straight for the slightly more general approach of just returning the square that we passed in. That should be sufficient to pass this test. We know it's not going to be sufficient overall. So we're green again. Everyone up to that point? So now we need to write another test that's going to break that. We land on square 2. That's our ladder to 38. We saw earlier. So that we would expect to return a 38. And of course, if we run that, it breaks because it's just going to return the square we passed in. Now we have to deal with our portals. So this is where we need to do our little dance with the iterators. So we write something similar to what we did before. These are the square that we passed in. But now, instead of asserting whether we have the iterator or not, we can actually do something with it. We're going to say, if we are not at the end, so we did find a snake or a ladder, then we can return second dot target. Otherwise, and the else is redundant, but could be useful to put in, we return the square we passed in. Does that make sense? Which end passes? Everyone got all that?
Almost. 0 bugs there.
Sorry?
0 bugs there.
Okay. All right, so we've got an empty square, we've got a ladder, we should put a snake in as well. I think the first snake was square 47, which goes to square 26. I'm going to put a 0 in, just to force us to see a failure, because it does return 26, which is what we wanted. And then you can make it go green. Now ideally, we would actually force a separate array here, force us to implement something different for snake, but C++ doesn't really give us the tools in the language to make that easy, so it's going to leave it at that for now. The next interesting test, I think, is going to be square 100, which, if you remember, is the winning square. So the question is, what should that actually return? Because it's going to return 100, as we currently implemented it. But we know this is the winning square. Whose responsibility is it to detect that? Since we have a board object here and we're raising the level of abstraction, I would argue that it's the board that should be responsible for detecting it, and therefore should probably return something different here. So what I'm going to do is, well, let's comment that out for a moment. Come back up here and add a new struct. I'm going to call it action. So this is the action to take when you land on a square. It's going to have another enum class called type. This time it's going to be either a move or win. So in the move case, that's what we've been doing so far, but then we have a separate case for win. So we need an instance of type, and uint32 target again. So it looks very similar, but different semantics. So, everyone got that? I'll come back to it if you need. What I want to do is now change this return type to action, which means I'm going to have to wrap our returns here with action type move. So are you familiar with the syntax brace initializers? You covered that. And also the type here is optional because it's inferred from the return type. You may prefer to keep it there for documentation. It means we can be fairly succinct about how we write it. So you should end up with something like that. Now we need to change the tests, because now they're returning actions instead. So we could just do dot targets, and that will get us back to where we were. Should compile. But I'm not that happy with that, because that doesn't account for this new information we just added, the fact that it's a move. What I really want to do is compare it against an action. So we put action type move there instead, and just copy that. So we can do it on each line. Is this making sense?
Is it convenient to create actions outside of the board?
Sorry?
Is it convenient to create action outside of the board? I will create it inside because I don't see how action can be used on their own, but maybe a different pattern.
You're saying we should declare action inside board?
Yeah.
You could do that. But the one downside is...
You have more experience, so you probably put it outside if there is an advantage, or you keep it so separated. I don't see how action can live without a board.
You're right, it is an implementation detail of board. We could do that. Trouble is, see here, we're already saying action, : type, : move.
Okay,
if we put it board, it's going to be board action type move. It does get a bit verbose, and I've missed something there, haven't I?
Using statements.
I would use
Phil, can you
Right.
Yeah, using statements.
for a second?
Type,
Because I didn't manage
using
it was too quick from the top.
Yeah, I use
Distribution. If you could just scroll to
Oh, yeah.
introduction.
Yeah,
The other alternative is you can analyze everything that instead of using.
It's basically the same as portal, but with move and win instead of snake and ladder.
using can read it now. Namespace is
That's
just
maybe I will tell you.
yeah.
So there is a compiler error here, which is valid. It's actually the next point I needed to come on to when we're caught up. Are you there yet? Yeah, good. Okay, so the reason it doesn't compile is because we can't automatically compare these structures. We're going to need to write an equals operator for it. Because we have C-line, we can get it to do it for us. We do the markets command N. It's not telling us what it is on Windows, but
Generate, yes?
yeah, generate. You know what that one is?
Right click on generate.
Sorry?
Right click on pick generate.
Yeah, you can do that as well. From the right quick menu, generate. And then we can say quality operators. So we can take type and target into account, generate not equals as well as equals. Now, we could generate it not as class members, because we're really only doing this here for the purpose of our testing. We don't necessarily want it in the production code. If we did, we could do it as class members if we wanted. I like to use standard tie, we'll see what that means. Generate in place just means rather than separate definition and declaration, we'll do that as well. So if you get your options looking something like that, and it's still done them in the class for some reason, but you can just move them out because they're friends. Just put them afterwards and take the friend keyword off. So did everyone get what we did there? So we've actually got C-line to generate these for us.
The reason it generated us friends inside class because we were there with the cursor?
Maybe, but we had to be there.
It's not, but it's actually in many ways the right thing to do.
Sorry?
It's in some ways it's the right thing to do.
Well, yeah, but I did say not to do it in the class, so it shouldn't have done.
Well, technically they're not class members.
I mean, if it was actually a class and these were private members, then it would be the only way to do it. Okay, so standard tie, by the way, actually just combines these into a pair or a tuple so that it can use its own forwarding onto the equals operator just to save a bit of noise. Just reads a little bit nicer. So that's just saved us a bit of work for doing that. That should actually now compile, I think. It does. And does it run? It does. Excellent. So is everyone green?
On the standard not, sorry, the not equals operator.
Sorry?
The not equals.
Yeah.
Is there a difference between doing not RHS equals RHS and RHS not equals RHS?
Yeah, with loop, you get stuck in an infinite loop because it would just invoke the same operator.
Yeah. You could do equals in terms of not equals and then implement it properly in not equals. Yeah.
It's curious that it's put RHS and LHS the other way around.
Oh yeah. It generates them in the inverse order.
Yeah.
Also, if you're not using clan, you might need to include tuple at the top. So these
oh yeah, that's a good point.
So what was that?
For standard tie, you probably need to include tuple. Map seems to
Yes.
drag it in on a Mac, but it might not on.
Yeah. Yeah. There is one problem. Sometimes things are included as part of another header. You might miss it, but if they are missing, you can use that authenter trick to give you the right include, usually. Okay, so we got back to pretty much where we were, but now we have these actions here. We're now ready to tackle this winning move. So what we want is an action where the type is win. And then what about the target? We're actually not interested in it this time, and arguably we want a better design where we don't have to think about it. What we should probably do here, instead of always having target, is actually have different types for move and win and hold them all in a standard variant. But we're starting to get a little bit too deep into topics outside of what we're talking about. So I'm going to leave it as it is for now. Instead, rather than hard coding a value we're not interested in, we can go back to just directly comparing against target here. I think that's going to be the better course. So we're just going to.
You mean type, target?
Sorry? Is that?
Do you mean type rather than target?
Type is win or move.
After 100, the parenthesis is also type.
Did I not?
Doesn't need to be the actual class instance. Oh wait a minute, sorry.
Type 3, yes. I was looking at the wrong thing. I see what you mean now. Absolutely right. Yeah. Dot type. That should be. Well, it won't be green yet because we haven't written the code. So we're back in the red phase where we should be. So it's telling us that 0 doesn't equal 1, but actually we're comparing enums. And the reason for that is because Catch doesn't know what the values of our enums are. We can actually fix that, although it's a little bit of boilerplate. So if you look in the snippets, I've got action type printer, and just declares an O-stream insertion operator overload. I don't know if you've looked at those before, but it's just a way of, if you stream this particular enum it will actually print out these strings. So you can grab that and put it somewhere after action. Try that again.
You could also add this source file to the CMake, right?
Sorry?
Like, since you've already got the source file, you could have just added the translation unit to the target.
Well,
You still need the
Oh, you need that.
we're only doing this for just to save typing. Normally we would be writing this here, but just to save this enough. Now, you notice I've got this default case in here, which is not a great way of doing it. And ideally, we'd rely on the compiler or static analyzer warning us if we've missed a case. But just to make sure we don't miss one, it will fail at runtime if we give it one that doesn't recognise. If we run that now, the failure message actually tells us the names of the enums, so that can be quite useful. Now in catch, because we're only really doing this for the purpose of testing, there's another way of doing it in catch where we do a specialization of catch string maker. I'm not going to go into that now, but it's in the documentation. This is just slightly more general, but we'll come back to that in a moment. So now let's make it pass. Should be fairly simple. Just at the start of land on, we want to tell whether our square is square 100, and if it is, we return action type win. Sorry, we need hold action, don't we? Again, it doesn't matter what we use for the target because we're not interested in that in this case. And now our test shouldn't be relying on it either. Did I miss something else? See, I'm just not catching up. Oh, that's great. So that should now pass. Everyone else there?
Yeah.
Okay, good. Now, one thing we haven't really done much of so far is considering that refactoring step. And right now we have this magic number in our implementation code. So I want to just address that while we're green. So we did say that knowing what the winning square was should be a property of the board. So we can actually make it that directly by saying we're going to compare against size, and we should be able to create a new field called size. We'll make that a static const as well. Give that the value 100. So that gets rid of our magic number, but it's still in the board code. Now we can tell that we're still green. Okay. Everyone okay with that? I think the next interesting case is actually square 80. And the reason for that, if you look up in the portals, square 80 is actually a ladder to square 100. And that means it's also the winning move. So we should expect it to be a win. But of course it fails, because the check for square 100 comes before we do the mapping on the portal. So we're obviously going to need to move our check down to the bottom. To actually do that with this. And in a moment, the C line should grey that out because it's unreachable code there, because we always return from one of these two branches. So that's not going to work. What we need to do is get some sort of intermediate variable to hold the mapping before we check against size. So something like U32 final square. And got a little bit of a problem here, because what we want to do is just assign that to the result of this block. But because C++ is not a functional programming language, we can't do that directly. So we might think we would have to have some temporary variable here, mutate it in here, and then use it down here. But there's a better way, which actually gets us much closer to what we wanted, which is to declare a lambda here. You covered lambdas, I presume. Stick all this code inside. And then immediately invoke it here. What we're going to do is take off the stuff to do with the action for now, because we just want the uint32 here. And we'll put it at the end instead. So I know I've done a few steps in one go here. Give you a chance to catch up in a moment. So fix this. And one is I think it's a problem. No, it's just C-line. We'll catch up in a minute. If we're doing it that way, we should have to make that auto as well. Does that make sense? I know it's a slightly unorthodox move there, but I do find this really useful because it minimises the number of moving parts we have to think about. We don't have any mutations going. Should be able to run that now, and it's actually not working. That's because I need to change that to final square. There we go, now we're green. So our land on method is now 2 stages. This stage maps our input variable to our intermediate type, or intermediate value, and then the second part maps our intermediate value to what we wanted in the output, slightly enriched. With no mutability involved, it's quite nice. Okay, everyone caught up on that?
Almost. The bottom, the 80 square. At
This
the
bit?
bottom. Yeah.
Just the same as the 100, but with for square 80.
Is this how developers are actually, like the process that you took us through, is this how they're actually doing? Because I guess my understanding of TDD as a designer would go through the process and where possible errors could arise, and you take little areas of that, and the code would be mapped to those processes.
I think you might be thinking more of BDD or ATDD, acceptance test driven development, when you get outside designers and testers involved. When you're just doing TDD as a solo developer, it's you that's driving the development of the code for your own tests. So yeah, it's these short feedback cycles and short loops between test code.
But so then as a developer, wouldn't you have to do it twice? Because if you're doing this for yourself, but then you work in a team with designers, they would expect to see katas that reflect their...
So you may have tests at different levels, or you should have tests at different levels. Here we're working mostly at the level of unit tests, which is in the code. So it's the low-level design of the code that we're driving. So yeah, you may have tests that are more closely linked to high-level requirements that you also need to fulfill, and they may be defined by designers or business analysts or someone outside of your immediate team. That's true. So yes, but you're not really doing the work twice, you're doing it at different levels, which is a slightly different idea. And most of the tests will be at this level. Does that make sense?
Yeah, I just, the unit tests that I've seen are actually very similar to this.
Okay.
But it's just, I would expect to see both sides of it, the design, the process side, and as well as the code side. Because then, to me, it becomes difficult to follow each developer's presentation style to ensure that the process matches. But yeah, we're learning. So
Yeah.
it's all good.
Some things like that are things you have to work out with your team, whether you're going to adopt certain conventions or do it a certain way. And one way that will help there to converge on a common style is to use the BDD mappings.
Okay.
So what we're doing here is the more traditional testing of test cases and assertions. With the BDD style, you have a scenario instead of a test case.
Yeah.
And one thing I haven't shown is sections. So we might look at that later if we have a chance. And sections could be mapped onto given, when, and then.
Yes.
And then that also helps to name the test as well in a way that it describes it. So yeah, if we don't actually look at the code, I'll actually show you a slide with an example of that on a little bit later. Yeah. Okay. So there's one more assertion here that I wanted to write on this this board logic, and that's what happens if you go off the end of the board. Because if you remember from the rules, if you're one of the last few squares and you throw a die that's too high, you miss your go. So what do we want that to return? Probably want another enum type. Let's call it no move. So we'll put that in our enum here. Now, you may have noticed we don't have it in our switch here, but we're going to assume for the moment you've forgotten that and just see what it actually tells us. So did I put that in the right place? Yep. If you run that, it fails of course, and tells us that, what did it tell us? It tells us that the assertion failed. So we can go and fix that by adding our no move case. And that should now fail in a more informative way. So everyone added the no move case? So fixing that one is going to be easier. Sorry, you want to?
No.
Okay. So we've checked whether the final square is equal to size for the win. If it's more than size, then we know we want to do a no move. Again, we're not interested in the target in that case. Capital N.
Shouldn't you return the original square?
Sorry?
Would you not return the original square?
No. Well, you could do, I suppose, if you wanted to say where you actually want to end up, but depends what you're going to do with the value. We haven't gotten to that bit yet. And when we do, we'll have a test for it, and so we'll catch that if that's what we decide to change it to. But for the moment, we're just not interested in what that value is. So I've still done something wrong here. Still got a missing capital T.
Sorry, you may have covered this before, but check uses the OStream operator, does it?
It will fall back to the OStream operator, but it will first try a specialization of catch string maker for your type. So it gives you a way to do a catch specific serialization if you don't want to use the OStream operator. So you get a few chances. Okay, everyone green? Good. It's unfortunate that in C++ we can't do much better than this if, else, if, else. In languages with more powerful switch statements or full pattern matching, we could do this in a single switch. But we can't do the greater than signs in a switch in C++, unless someone knows something I don't, they've added recently. Okay, so I think that's pretty good. And so we've got these two mappings now, all fully fleshed out. Right. I'm going to change the name of that test case to something more meaningful now, which is that board. Didn't think of a good name actually. Tells us what happens when we land on a square. We can be really descriptive in these names. Maybe that's a bit too wordy, but we can just use freeform strings there. Okay, what time are we running till? 9.
9. We'll be
Okay.
picked up at 9.
So I've got a bit more we can do on this to tease out a few more details if you want to carry on with this, or I can show you a bit more of catch in general. What would you prefer to do?
Guys, and girls.
Well, we could have a little bit of a break first if you prefer. It's a good place to.
Sorry?
I'm easy either way.
Do we want to let this guy out on the break and I will disappear?
Yeah, maybe that.
I will hold him.
Yeah.
Wow.
Yeah, I could do it in a couple of minutes.
Let's see.
Yeah.
Can I ask you? It's failing on one of my tests. I was trying to catch up as quickly as I can. But is stretching with this one. I don't know why. On the square 80.
So that's yeah. You did the same mistake I did first. That one needs to be final square.
This one.
That square equal size.
This one.
That was the purpose of getting intermediate variable, so you could check after it's been out.
Cool, thank you. So 5 minutes break?
Yep.
So it's not basically the idea to do a whole project. It's nothing huge. It shouldn't take you about next to hours. You know, if you think you've learned enough and you want to do it, sure, because we can enroll you for it as well. Okay. So
it's a week though, right? It's a week.
you get a week for it, yeah. So there's an NDA. I'll just say you promise you'll publish it on the internet. Just write your name there, just sign there. If you want to allow us to share your results with other people by email, sign that up. If you don't, you can still do it. You have to give us a written letter to say that we're allowed to.
Is anybody able to compile this?
You mean this?
Yes.
Yeah.
That's what it was.
It's catches throwing us.
Yeah, look.
It was very quick. You know, I was like, ooh.
Well, why? Oh, don't connect. You should not. The problem is you actually want to include the header, and it needs to see that defined in order to actually generate the MA. It's just an if definite file. It's quite a big issue.
Yeah, I think obviously new class, maybe if you have a bigger screen as well.
Hopefully we will. We've got quite a number of people coming, so they're not going to fit all of us in it, which means we should get
Very hard to walk past the smell of all that pizza. Trying something.
We're not allowed to touch.
Yeah, we did.
We've been told
Got a
that.
telling off.
A few seconds for more coffee.
Before we do carry on, anyone got any more questions either about what we've been doing or at a higher level?
I mean, too quick to ask the questions. I mean, it's like
Take a while to assimilate.
yeah, it's like going like a massive float. But it's making more sense, you know, with the how it's structured. So I suspect, you know, well, at least my experience is like the first time you've been exposed, so it blows your head.
Mm-hmm.
Then the second time you prepare for what to go, yes, you know roughly what to get, and then like 10th time you go, so you start putting things in the right place.
Yeah. Well, that's exactly the value of doing these cartas, is you can go over them again and again, try something different, or you can just make sure you do things without having to look them up.
Do you have like some sort of examples with the solutions? So, for example, we can then try something very basic and like try our solution, and then let's say compare to your solution. Do you have something like this, maybe?
If you Google for coding cartas, you'll find lots of sites that have catalogues of cartas. Some with examples of mainline workflow, some with just a problem statement. But it depends what you're using them for. Often it's
Cookies are okay. They're always there. We're allowed to.
sometimes you'll use them because you want to just try out different solutions. So there's not necessarily one prescribed way to do it, but it can be useful to see what other people have done.
Yeah, but because at the moment, yes, as like when you understand, you know, you put this here, you put this here, yes, then it's fine because then you. But when you first time come, you know, arrive and it's like empty, empty page, and it's like you still like, yes. What should I put? What I'm missing? Yeah, that's the thing. Is what I was referring. It's like if I have something to compare against, then it's like in the CPP reference. The first part I check is not the top of the thing upstairs. The part at the bottom with example. Like, I see. And then try to play with it.
Funny enough, TDD, or particularly BDD, is sometimes called specification by example.
Oh, okay.
You're writing examples of how to use the code in order to specify it as an executable specification.
Okay.
And we'll look a little bit more about that in the next one.
Cool. Thank you. Are we ready to resume?
I'm ready when everyone else is. So
1 minute maybe?
one or two people still outside, or
I think they're getting coffee.
to pick it up.
Make any games?
Sorry?
Do you work in Unity or Unreal in C++?
I don't, no. I have written some actual games before, but not those sort of games. More like this actually.
In C++?
Strategy games. Yes, although the main one I did was an Objective-C on an iPhone, but there was some C++ in it.
So the tests you wrote for that was pretty straightforward to write for games?
but the tests I wrote for that were pretty much non-existent. And I got into a lot of trouble because I couldn't change the code in the direction I wanted it to go. So I started looking around for a test framework that could test Objective-C and ideally C++. Couldn't find one that I was happy with, so I wrote my own. And
Oh, wow.
that's how Catch was born.
Oh, really? From the game?
Yeah.
Oh, okay.
So originally it was primarily for Objective-C, because you can link the two languages using Objective-C++, which is this horrible hybrid. So you can still use Catch to test Objective-C code as well.
Oh, wow.
I think that we tasted it actually.
Okay, are we... Sorry?
He has one of these bowling games.
Yeah. Yep, that is one of the more known ones, yeah.
This reminds me very much.
I think that's a good thing.
He's been pretty successful. He's doing something right.
Yeah. Doesn't do everything right.
There are people with a difference between
Probably a good time to get started again. After Tom takes a photo, obligatory photo.
Yep. I got a bad habit of forgetting to take photos.
Sorry?
I got a bad habit of forgetting to take the photos.
Yeah, I'm saying.
And then, when everybody's almost packed, we're like, oh, hold on, photo.
Before we carry on with the code, one of the things worth pointing out, since we're in C-line, every time we've been running it, we've been seeing the console output at the bottom, which is actually my preferred way of doing it anyway. But C-line has a built-in test runner that works with Catch. So if you want to use that, if you go to the configurations dialog at the top and say edit configurations.
Where is the configuration, sorry?
So the bar at the top,
yeah,
you should see Snakes and Ladders debug. If you drop that down, you should see edit configurations. Yep.
Yeah.
Yep. And then in the top left, hit the plus and select Catch from the list. Should we fourth one down? Let's give it a name like tests if you want to be boring. There's all sorts of options you can put in there, but then when you run it, you'll actually run in the test runner and you'll see on the left hand side all the tests, which we only have one at the moment. You can see it all green, and the actual output will be on the right hand side. Just a slightly different way of seeing them, so that could be worth doing. Sorry?
Tells you the individual runtime for each test.
Yes. Yeah. In fact, this will become more useful in a moment when we start doing nested sections. First thing I wanted to point out is that so far we've written all the code in the same source file as the tests, which I find a really useful way to start because it gives you like the minimum swapping between the code you're testing and the actual test itself. But obviously at some point you want to move that code into its own source file, maybe in a separate project. And it can be useful to do that once you've got a substantial amount of it under test. Then you can switch to thinking about that sort of more infrastructure stuff. I was thinking we could do that now, but actually it's probably going to take up too much time. So we're going to assume that we've done that. And what I want to do now is start a new test case. We'll give it a name at the start. Let's call it test game. Come up with a better name. Actually, no. Scratch that. I want to make this a scenario. We'll fix the name when we have a better idea what we're doing. So, as I was mentioning earlier, scenario is mostly an alias for test case. Just gives it a little extra prefix as well. But it's a very different way of thinking about things, as we'll see. So what I'm going to say now is, so first of all, has anyone here actually looked at BDD. But it's not strictly BED, but it's commonly associated with it. There's a way of breaking down the test into 3 stages: given, when, and then. And we call these things a scenario. The idea is that we say, well, given this set of resources or this data in this state, when you do some action, then you'll have some test result. So you can define those 3 stages, and you actually document what you're doing along with those, and it reads as a human readable scenario. So that's what we're going to do here. So as aliases for sections, which we haven't looked at, but we'll see how they work. We say given, all in caps, a game with 2 players. And we have a block. What we need to do then is actually create a game with 2 players. Now, we haven't written a game object yet. Again, we're going to drive that from the tests. So first of all, the game object itself. Again, we could do create new class to create it in a new file, but because we're keeping it all in the same file again for now, we'll have to create it up here. Let's make it a struct just to keep things simple. Anybody know the difference between a class and a struct, by the way? Have you covered that?
Yeah. Access.
Yes.
Private and sort of public.
Yeah, so it's purely about access.
Inheritance is different.
Only for the access. It's the only difference. So I often use structs when I'm just getting stuff up and running, just to keep things simple, assuming that everything's going to be public. Okay, so we've got a game, so that compiles, but we actually want to give some players, and players in stakes and ladders just have different colours. So what we want to do is be able to pass in a list, or initialize a list in this case, of colours. So we're going to assume we have a type called player, with an enum called colour, and we'll say blue, and another one, green actually. So, no, it doesn't work here, does it? In fact, what I did was, did I put it here? No, I didn't. Thought I had a snippet for that. I do. So we'll need to create struct player, enum class color, and we need blue and green, and we'll give it a couple of others as well. And we need to use that color. Pretty straightforward so far.
Do we need these extra colors?
Sorry?
Do we need this extra?
Well, we don't need them at the moment, but we're only actually going to get as far as 2 colours, but in theory in the game we'll be able to randomly choose them or something. As long as you have the blue and the green. Okay. So that's still not enough to make this compile, because we need a constructor on game that will take that initializer list. So, have you covered initializer lists?
Mentioned them in the past, we haven't actually
Okay.
shown how to create an initializer list constructor.
All right. So standard initializer list should auto-complete for you. You can think of it like a lightweight vector. It's probably the easiest way to think about it to start with. So it's going to be of player colours. But we don't need to take it by const ref, because it's very lightweight. It's all hand wavy. That's just called colours. Okay. We won't do anything with that for now, we just need to make that compile. Everyone done that? That should be enough to compile.
Yeah.
So we have our game with 2 players, we've satisfied the given. Then we need an action. We say when, in fact, before we do that, I don't want to assert on something else, because I'm going to assume this game is keeping track of who the current player is. So it's going to start with the first player. So let's assume that we have a member variable. Let's call it player index. It's going to start with 0. So we probably wouldn't make this public in real code. That's why I made this a struct, just to keep things simple. We obviously don't have player index yet, so usually we should be able to get. Oh, no, wait. There's a problem in C-line at the moment where if you're in a macro, it won't do the create from usage. If you pull it outside, it still doesn't work. There we go. Nope. There we go. We get it to create the field for us. It's unfortunate. I'm hoping that will get fixed. You can always do it manually.
And is that created inside the struct game within after the initialize?
It can be anywhere.
Okay.
It doesn't matter because it's all public. I actually generally prefer to put my member variables at the top, but it's a matter of style. So we do want it to initialize to 0, which should make that pass.
Just as an aside, is it possible to give a friendship relation to something inside catch to allow you to look at member variables, otherwise private member variables?
That's a very good question, and there isn't a built-in way of doing that in catch, but what I do sometimes do something a bit more ad hoc, where I grant friendship to some object that I forward declare and then only define in my test code. Achieves the same sort of effect.
Proxy object.
Sorry?
Proxy or accessor or whatever.
Yeah, it's an accessor thing. And then I just put a comment by it saying it's only for testing.
Make unique and make shared, be able to call private constructors.
To do what, sorry?
Usually make unique, probably referring to private constructors as well.
Right.
So it's similar to that.
Yeah. In general, the other reason it's a good question is, it comes up a lot. I mean, how do you test private members? The default answer is actually you don't, because you want to be testing the publicly observable behavior. There are some times when you do have to. And one example that I've had to do this for is when I've written a reference counted object and I wanted to test that the reference counts for a certain value, but normally I didn't want to expose that. So I use this trick to just expose it to the test code. Okay. So then we've got a starting point. We can say when a turn is taken, so we're going to need to actually take a turn. So assume there's a method called take a turn. Again, we don't have it. We can create it. We'll return void for now. That's fine. So that's all we need for that to work. Then we advance to the next player. So we're sort of telling the story of what the code needs to do in these given when then scenarios, and then writing the code to match that. So we can now say check that player index is equal to 1. And you'll see why this is all indented in a moment as well. That builds should fail. Now you see a failing test in the test runner.
Would you mind to show the take turn? Where is it created? Is it under game?
So I just wrote the method name, and I did Alt Enter on there to get something to create it for me. In the game object, yeah.
Game function, yes?
Yeah, it's just a member function. Just empty, void return.
Okay.
Okay, so we're just to make it compile and run. So now we actually need to take turn to do something. So what we want to do, of course, is advance player index, because that's the minimum step to make that pass, which it should. We run it, it does. Which then forces us to write another test to make that do something else. So then we can say, and when another turn is taken, so take another turn, then we return to the first player, if I can spell it correctly. Which means player index is now 0. Which of course should fail again. And you can see now in the test runner that nesting is reflected in this sort of tree view. We've got the given when thens. I actually prefer the command line output on this. If you select the snakes and ladders target and run it again, what you'll see is that the test name is now a complete scenario description.
That's great.
I thought you'd like that. So we've got scenario, test game, do better than that. Given a game with 2 players, when a turn is taken, then we advance to the next player. And when another turn is taken, then we return to the first player. That's the bit that's failing. Yeah? And here's the failure description. So every time you get a failure, you get this complete scenario description up to the point of failure in a human readable form, more nicely formatted. Which is actually a really nice way of working. So I think it's worth having that pain of all the extra indentation to get that. And we can also match the human readable description of what's happening to the code that's making it happen. So if we make a mistake in the test code, we should be able to spot that easily as well. So let's get this to work. Is everyone caught up with that so far, by the way?
In Catch 2, is it still really, really quiet when everything just works? So you get that summary at the end with nothing in between?
Yeah. But this is Catch 2.
Oh no, I know this is Catch 2,
yeah. But
that's failing, so it's printing out.
It's failing, yeah. But you've seen it passing before tonight, haven't you? I hope.
I think it was miles away, so I missed it.
All right, well, we'll see it in a second. So, coming back to here, we now need to detect when we've hit the number of players, but we haven't actually stored that anywhere because we just took this initialized list of colours in at the start. So we're going to need to somehow store that. There's a few ways we could do this, but we're going to want some sort of vector of players. So let's add that. Vector of player, shall I say. And then we want to initialize that from colours. Technically, all we need to do is actually resize it. It's not going to work because we'll need to give it a default player. Is it going to work? I haven't tried this actually.
Can you reserve it instead?
I could do, but that won't change the size. We want to compare against the size.
Oh, you're not going to iteratively stick them in?
That does actually work. So it has default initialized each player. It's not really what we want to do though. What we want to do is initialize each one from the color Did I have a snippet to do that? I forgot what I did now. Don't think I did. Okay. What we'll do is we'll do it the easy way. And do before that, we'll change that to reserve as you suggest. And do for choose the colours, aren't they? So we don't need that. So for each colour in our initializer list, we'll push back or replace back then we should be able to do colour. You do that?
No, because you're trying to. Oh, yes, actually, that will work.
Move that to do auto and colour, and then stood move it.
There is a much easier way to do it.
Well, because we could send a copy.
No, just because initialize list has begin and end, so you can just do the initial.
Oh, do the constructor copy. Yeah, that's true. Yeah, I was thinking we'd do a standard copy. That should be colours. So Tristan's suggestion is, I think, to just do.
Oh no, sorry, that is. No, I'm being
because it's a different type.
Yeah, I forgot we're not passing initializers to player, we're passing initializers to class.
Yeah.
Sorry.
So that?
Foolish of me.
That is not right. What did I do wrong there? Okay, it's not going to let us do that then. So we will have to do player.
You should just be able to pass the arguments of player.
Well, that's what I was trying to do.
Oh yeah, so is that
yeah, players players an aggregate doesn't have a constructor, so you can't use.
Yeah.
Because in placeback tries to use the round bracket syntax, which doesn't work.
if you added an explicit constructor to player, I don't mean explicit keyword, but if you added a constructor to player,
Yes, that would work.
So the proper way to do it is, instead of using a loop, to use an algorithm. If anyone came to C++ London last night, that's what we were talking about.
Listen to me ranting.
Unfortunately, it does get very verbose. It's not too bad here, actually. I think it's just colours begin, colours end. But then you have to use standard back inserter. Have you covered all this at all?
Yes, we had
Okay.
a couple of sessions about
But that's not quite. We need to. Yeah, we need to use standard transform. This is why it gets a bit awkward. Let's stick with the for loop, because we're digressing a bit too much, I think. So we've got our for loop, we've populated our players collection, we can now test it and take a turn by saying if player index is equal to the size of our players vector, then we can reset player index to 0. That was all we needed to do at this point. We will need the players collection in a moment anyway. And that should now all pass. So there's your minimal output.
yes, okay.
So we can see how many assertions and test cases passed. Okay.
It took me 2 minutes to find the argument to make it not do that.
Dash S.
Yeah. Oh yeah, well no, I know. Well, once I found it, that's it. I memorised it.
What time? What did they here?
So here we just tested the side effect of taking turns. But we probably want turn to actually return something that tells us what happened. So let's assume that it does. and we'll go and change take turn to return a turn info. Should be able to get that to. No, it wants to do it in a separate class. I need to get onto them about that. So another struct, return info. It's going to have a player, the player that actually took the turn, and an action. That's the one that the board returns. Okay. So now take turn is going to need to return turn info, which needs a player. So we can give it players indexed by player index, which will be the wrong player at this point, but that's what we want for now because that will give us a failing test. And an action. So let's give it a no move. Remember, the simplest thing that will compile. Sorry, that should have said turn info up there.
Change your turn target.
Yeah.
It's probably worth mentioning that the act of actually making it fail first is good, because if you just write a test and pass it straight away, you have no idea if something's wrong. So you want the red and the green and the refactor.
Yeah, if you've seen a test go from red to green, you have much more confidence in it than if you just pass straight away. Because hopefully you know exactly why it passes now. So that should.
So if the test could pass but there's nothing executed, for example, that's bad.
Or you're running the wrong thing.
Yes.
Right, so that now gives us this default turn object. Has everybody added take the turn info? So now we can start testing against that. Now this is interesting because this branch here is going on to look at what happens when we continue taking turns. We actually want another branch here where we say when a turn is taken, then we get back the player and action. So let's test that.
You need then within the description.
Sorry?
You need then within the description.
Oh, sorry, yes, redundant then. Thank you.
Take turn.
So we can test the player color. Because we know the first player was blue, and it's the first turn, we'll test that that's blue. And we'll actually go on and do the action as well. Getting ahead of ourselves, but now this is an interesting part because what do we expect the target to be? Now we're actually building a real game object. We would expect this to be the result of rolling a die. So it's going to be random. It doesn't mix well with testing. So let's imagine for the moment that we have some way of fixing the die roll to 1. So if we've done that, we should now expect to be on square 2, which is a ladder to 38, so we want 38 here. That will obviously fail for now. Let's see if it runs. Should get 2 failures. We do. So we've got the wrong player because we're returning the second player, and got the wrong square. So now we can go back and fix that. Everyone that's following with that so far, or do we need to scroll back?
He's missing the turn info struct.
Yeah, this is right. Turn info has a player and an action.
This one.
construct them. So we turn on the fix the top. Fix that. Where's the down bit? Yeah, that's the turns down there.
Can you read that?
Plays by index. It's index memory, so we're around. Your index of plays is one player index. Plays is the vector.
Thank you.
Yep, good. Have you got the tests?
Okay, don't worry. Don't wait. I'll catch and push it to
All right.
get up after.
So the first failure, I get that back there. Oh no. Run it again. Okay. The first failure, because we've got the wrong player, is because when we reference it here, we've already incremented it. So we need to catch it earlier. So what I'm going to do is extract variable, which on a Mac is Command-Alt-V. And then I can say, let's make it auto, call it player. And then grab that line and I can move it up to before we increment. Make sense? That should fix the first test. It does. The second one, we need an action. So for this one, I'm going to assume we have a variable called action, which I can now alt-enter to create local variable. And this is going to be the result. Oops. Do that again. The result of calling our land-on method on board, except we don't have board yet either. So we can also alt-enter that. Create new field. Get the type. Now we can write land on the player's current square, which we also need to add. And default that to 1. I'll do multiple steps here again, so we need to come back to this and add that to the roll of a die, which we also need to create a new function for. I'll leave that at 0 for the moment so we can catch up. So let's just go back over what I've just done. So we added a board member, not in the sense of a committee. We called the land-on method on it. With player.square that we had to add to player, and added a call to roll die. So quite a few extra pieces there. But we should probably split up, but we're running short of time. Shall I carry on?
We've got 6 minutes and then I'll get across the list.
Yeah. All right. So, where's roll die? Now over in the snippets, we have roll die. So we can grab that and drop that in place. That's going to rely on importing random or including random. It's not the nicest random number code. It'll do us for now. Don't worry too much. Don't pay attention to the wizard behind the curtain. There you go. So I actually used a different naming convention. So so you won't change that if you do the same thing. That should be enough to build and run, and will mostly fail, but will randomly succeed sometimes. So you might need to leave how to fix that as an exercise to the reader. But the clue is it will involve lambdas. I think it's going to be better to just do a summary at this point. So we scaled up from just using the assert macro as part of the C and C++ standard library to doing test cases with assertions, saw different types of assertions and how it gives us more information. We also moved on to using this sort of BDD style, using scenarios. We have given, when, then. In fact, one thing we should look at again is now what this looks like. So now we have a different scenario. Given a game with 2 players, when a turn is taken, then we get back the player in action. Notice that we're reusing the first part of the scenario. We've actually got effectively 2 scenarios now. What happens is that each of these sections, given when or then, every time catch encounters one, it will execute that one and all of its innermost sections, skip over the rest, and then go and execute the scenario again, skip over the one it saw before, and execute the next one, and so on until it's covered the whole lot. So every leaf section, like every leaf then, will be executed once, but in an isolated test case run. Does that make sense? Okay. Which means you can actually get quite a lot of test code written in quite a compact way that still somehow makes sense. If you do too much of this, it does start to become a bit unwieldy to manage it all. Eventually you have to split things up a bit more, but up to a point, it's a really nice way of organising your tests. So it's probably a good time, given we've got 2 more minutes, to ask if there's any more questions on that. Yeah?
I've always presumed that the reason we have bugs in the code is a neuropsychological problem.
It's a what, sorry?
It's a neurological problem. We cannot have all the states of the problem in our head. But are you just merely simply introducing more cognitive load with a test that's effectively a program, like your previous program?
It's an excellent question. Is adding all the testing onto it, particularly complex stuff like this, adding more cognitive load when we're already at risk of adding bugs because we're trying to keep track of too many things? The short answer is no. The longer answer is, remember back when I was discussing the TDD cycle and I said you've got these different mental modes that you go through. So when you're writing the test, you're concentrated on these design level things, and you only need to be focused on those. Then you switch to implementing the code, you're only concerned with making it green. And then you go to the refactor step, you're only looking at deduplicating, cleaning things up, and so on. So it gives you that focus. We don't have to worry about these other things, particularly because the test will tell us if we break stuff. And because those design principles that I said that tests will tell us if we're getting wrong are all about greater isolation, separation of concerns, and all those things, we'll naturally write code that is more isolated, so we don't have so many interrelated things to worry about. If we do, it becomes harder to test. But we see that earlier, and so we know to do things slightly differently. It's not the complete story. As I said, we do still need to bring our knowledge of design principles to bear. And a part of that, which I often recommend as well, is looking at sort of a more functional style of programming where we do minimize mutability, which is one of the things I've tried to bring out here, minimize interconnected things and side effects and all those things which lead to you having to track huge amounts of state in your head. Of course, there are still going to be cases where the nature of the problem just demands that, and sometimes that's one of the cases that TDD actually isn't the best tool, because you are just trying to cram a load of extra complexity on the testing side to match it. I think these nested sections actually allow you to use it a bit more than usual, because you can structure it in a way that sort of matches the state changes and track them more readily. But yeah, sometimes there is still a cut-off point where it's not the right tool. But you just need experience with it to know where that is. Does that answer your question?
Could you ever get to the state where your TDDs need TDDs?
Sorry?
Could you get to the state where your TDDs need TDDs?
Well, your TDDs need TDDs. Well,
that's mutation testing, really. The C++ doesn't really have it, sadly, unless there's a proof of concept someone did.
Yeah, there are some. I haven't really used them.
Yeah, I don't think they're not really like Java's. But the idea is you have what's called mutation testing. So someone will take your source code and your tests, mutate them, and run them again. And if they somehow still pass, it means something's probably wrong.
So that is one approach. Another is, well, more related to how do you test a test framework, which is a similar but exactly the same question. So Catch itself has lots of unit tests, which just sort of exercise features, but also test parts of the internals. It also has an external test harness that will run different configurations of Catch, capture the output, and just compare it against the previous run. It's known to be good. It's often called approval testing, or just regression testing in general. And you have to do a bit more sort of fixing up of the logs in between, but that helps me to make sure that I'm not breaking anything in the test framework, so that you can have a little bit more confidence in it when you're using it, which is, say, not exactly the same question, but it's definitely related. Interesting domain, I think, in general. Meta testing.
Yeah, because I can see this getting more and more complicated, and then you introduce a feature, and now you have to check the loads of tests. And is the test passing because the tests are broken, or is it passing because your code is actually correct?
Yeah. So the tracking for when you're going into these different sections and which ones you've already seen and so on is not rocket science, but it is a bit involved. And then I was trying to add extra features like data parameterized tests using generators, where every time it goes in, it will actually give a new value for a certain variable, so you can test different values in the same test. That also required you to re-enter tests and keep track of it. And adding those two things together made it much more complex, and I did introduce bugs. So I sort of backed out my first version of that and had to go away and from scratch fully TDD my test case tracking code. So using Catch to actually TDD like the next generation of the internal workings of Catch, and to make sure it's really, really well covered. And now I'm pretty confident in it, because that part absolutely has to be right. So far it's been pretty good the last few years. Yeah.
Relating to what you just said, so when you were trying to use the previous version of Catch in order to test the next version, how did you avoid like conflicting namespace type things?
So when I was doing the actual TDD part of it, I was writing new code that wasn't currently part of Catch. This is another way to really maximise the amount of isolation you have, because obviously I couldn't be dependent on most of the other parts of Catch while I was doing that. You could have some dependencies. But once it was all working pretty much as I wanted, then I can move it into Catch. I kept the tests there, but if they ever fail, then I'm going to be in trouble, because it will probably stop Catch actually running properly. So what I also do, there's some parts of Catch that are like a library within a library. One of them is the command line processor. I've actually spun it out as a separate library called Clara. So I have a separate repository with Clara in it, and then I run a script on that code that puts all of the code in an additional namespace and fixes up a few other things, so I can include it in Catch. And then I can use that version of Catch to test Clara independently, because there are different namespaces. So I think at that point you have sometimes about 3 different versions of things going on at the same time. It gets a bit messy, but it works.
Cool.
If we've got any more questions, we should probably do it outside in case they come and kick us out.
By the way, we're going to pub, so everybody's basically welcome to join us.
Yep, including you out there.
Yeah, and the last question, I mean, you put so much work into this, but it's obsolete because I hear that C++ developers don't make bugs. So how do you feel about that?
C++ developers don't make bugs?
Don't make mistakes.
No, they call them something different.
Yeah, they're features.
Yeah, often.
Or another word to give you that anyway.
Thanks very much. So thank you much. Really big thank you to Phil.
Yeah. So we've got Nash stickers if you want them.
Oh yes, Nash swag.
Stickers. Next week we're starting again. We're going from the beginning.
Okay.
Bring your friends. Tell your friends.
I think there's lots of people coming.
Yeah.
It's going to be busy.
Actually, don't tell too many friends.
Yeah, maybe not.
But there is possibility for an upgrade.
Sorry?
There is possibility for an upgrade if, like, I don't know, 50 people register, I assume.
As long as they register on Skills Matter, so they know how many people are coming.
Yeah.
If they've given us assign us this room, but we've got 200 people turn up, we're going to have a problem.
We're nearly at 30, so we should get a bigger room anyway.
Sorry?
We've almost hit 30, we're
Okay.
on 30.
But if we go to 200, as we over 200, then we might have to go to the main room.
If we start getting very large numbers regularly, we're going to have to start thinking about limiting it, because once we start doing lots of exercises, it's not very practical.
Yeah, there's only like 2 or 3 of us.
If we have a bigger screen,
If we have a bigger room, we'll have a bigger screen. Yeah, the other rooms are equipped with projectors.
So for those of you who are doing more copies of the NDA.
Thank you for that.
Oh yeah, it's fine.
I thought it looked fantastic.
Yes,
People use the behavior. This area.
You should practice already.
Yeah, I because it makes me want to practice the coding when I can see the. It's just the way I see it.
Yeah, I find it really helpful to come up with
Yeah.
There was a suggestion by another.
I really, because I know you didn't have to film, so I really appreciate it. Thank you.
Thanks so much for that. It was
How did you find out? Was it good?
Oh, he was lovely. Yeah, it was great. I shall come next week.
Yeah?
I will sign up too.
Sign up on the Skills Matters website, and then you're very welcome to come.
Yeah, it was very, I can follow it. I haven't done much.
Do you know our website?
You were signing in glass.
London Uni. London Uni. And if you go to that website, if you add the mailing list, you will have all updates. Plus on the website there is all